Good morning, and thank you for joining us. Today's webinar is on an introduction to the all SimPrep automated liquid handling station and is being presented by Jacob Herrington, our automation product manager. We will take questions throughout the presentation, so feel free to submit those using the question function, and I will go ahead and hand it over to Jacob.
Thank you, Shelley. Thank you guys for calling in. So we can talk a bit about the SimPrep system. As I believe you're aware, it's a new offering for Teledyne CETAC and kind of an updated look for offline dilution, something significantly more capable and flexible than what we've had in the past. So the system itself is comprised of essentially 3 components. There's the software, the Hamilton syringe module, and one of our CETAC auto samplers. The system can be run with the 560 or the 280, depending on space requirements within the lab. We also offer a SimPrep upgrade path for people who have an existing auto sampler that's not presently in use. They can use that to upgrade with the syringe module and the software. So that they can have a little bit more of a discounted way to get to the new product. So the big thing in my mind, my background in chemistry makes me think, well, how well does the thing work? Obviously, that's a big concern for any sort of a lab. It's great that it can push liquid around, but what's the actual data look like? So the nice thing is that Hamilton has an excellent reputation, and we're able to build off of that with some simple automation. So the big 3 in my mind is typically it comes down to accuracy, precision, and carryover. So we did a number of tests, and I won't go through all the data here. But essentially the accuracy, it varies a little bit with the syringe depending on how much of the syringe stroke that you use. So it is most accurate somewhere between 30 and 100% of stroke. And then, but even down at the 10th stroke, we're within 1% error. So the accuracy data there is displayed by percent error. And even at the 10th of a stroke, we're less than 1% error. So that's pretty excellent. Precision is right next to it. So that's the RSDs. So we essentially had it dilute samples 10x, 100x, and 1000x, and then ran them on an ICP to compare the data quality, and found that even at the 1000x solution, we're still within 1.3% RSD, which we were pretty happy with. And then we also did a carryover study where we prepared a 100 ppm standard at a 1 to 10 dilution directly. After that, we prepared a blank solution also at a 1 to 10 dilution. And then those were run on the ICP, the blank not directly following, but following a separate blank so we could get appropriate readback on any sort of carryover in the auto diluter. And the average carryover came out to be the 0.0038%. That you see there, which we were very, very pleased with. But the system does more than just diluting. That's obviously its main function for a lot of labs. That's what they'll primarily use it as, but that's not all it can do. It also can act as a dispenser if required. It can do serial dilutions. It can do splitting, which is basically it can prepare the same sample up to 3 different ways. So if, for example, you wanted to prepare samples for your ICP-MS, your AA, and your IC, you could have the same sample prepped 3 different ways across 3 different racks, and then rack 1 goes to instrument A, rack 2 goes to instrument B, and rack 3 goes to instrument C. It can also do standard spikes, and it can prepare your calibration curve. So a few specific applications that I thought we'd go into a little bit more in detail. One of them is serial dilution. So these can be separated by rack if, for example, you wanted to do a 1 to 10, that you'd have a rack that was a 1 to 10, and then dilute that again to a 1 to 100. So you have racks of sample that are different levels of dilution. You can do that across multiple racks, or you can do them right next to each other. In the case of a lab that needs to run the same sample at multiple different dilution levels. And that serial dilution function, of course, provides a much wider range, wider dynamic range to the system than it already has. Standard addition is a key step, whether you're doing sample spikes, matrix matching, internal standard addition, what have you. And essentially what it will do is it'll pull up an air gap, it'll pull up your sample, it'll pull another air gap to separate the sample from the standard, then it will go into the standard position, pull up your aliquot there, and then dispense it all into the tube. And then this is an example of splitting, which I discussed briefly earlier, where you could have the same sample prepared as a 1 to 10, a 1 to 5, and a 1 to 100 or a 1 to 1,000. And if one of those needed the sample spike, you can add it on just that sample. One of my favorite things about the splitting feature is that it runs the samples according to the final dilution, or final concentration, excuse me. So it runs the sample that's going to have the lowest final concentration first, and then proceeds to the highest concentration last. And it does that automatically, which is a really nice feature. The software itself is very spreadsheet-like. I mean, you can see here across the top, we've got dilutions 1, 2, and 3. And then on the side, you can see all the arrows. I've highlighted a couple specific spots. And they allow you to expedite a sample so that if you do have something that comes in that you decide you need to run this right away, you can select that specific sample to be run out of sequence, and it'll do the expedited samples first and then resume where it was in the run. And you can also exclude samples, which is really nice for if you have variation from day to day. One day you have 30 samples, the next day you only have 15. You can use the exact same sequence and then just take out whatever samples you don't have to run on that given day, and you don't have to go through rebuilding the process or changing the files. Some of the sequence settings are listed here. It's very flexible. So I mentioned there's an air segment option that prevents cross-contamination. There's also a no drop volume, which is to avoid any sort of drips. And then you can have it dip into the wash port, but it's all very customizable. The rinse is totally up to the user, and that can be removed entirely for things like dispensing. If you don't want it to go back to the rinse station, there's no requirement to. And there's also the option of mixing. So you select the volume you'd like to have it mixed and how many iterations. And essentially what it will do is it goes into the prepped sample. It'll pull up an aliquot and redispense it, which is a fairly rudimentary mixing, but it can be very effective. This example of a standard prep curve. So the sequences can be built for a lot of different things. Like I said, there's dilutions all the way to something like building a calibration curve. One thing I think is really nice in the software is you can type everything in by volumes, but if you'd rather type it in as a 1 to 10 or 10%, that's also viable within the software. It will read it appropriately. And we did do some calibration curve testing on this. We're able to get 4 nines and better pretty much across the board on a multi-element set of standards. And that was running off of a 100 ppm stock solution that we diluted between 10x and 2000x, and then ran on our ICP. So here's the calibration curve. And we're able to get very good linearity with it. and that came out really nicely for us. So one thing I wanted to make sure that we saw, we've got a little video here. If it will play, let me try. I have this in another window. Let me see if I can pull it up over there. My apologies. And that is not wanting to play today. Sorry about that. Let me see if I can get it from our website. Okay. Sorry about that. This is a simple test that we did. It's kind of a proof of concept that was specifically running coolants, but it provides a nice visual of the system functioning. So hopefully you can see all this and it's not too choppy. So you've got an initial rinse here, and that's, again, user controllable. So you can have that be a full prime of the system if you want, or just a small aliquot. Samples pulled up, the diluent is drawn. One of the really nice features of the microlab system from Hamilton is it does have the dual syringes, which allows you to handle large volumes, but also have the accuracy of smaller syringes. And Hamilton is able to provide us with syringes ranging from 50 milliliters all the way down to 10 microliters. So after it dispenses, the probe is rinsed. Again, that's user configurable. So it's up to the lab to program that as they will. And repeat. So now the video has been sped up to 5x speed. But it provides a nice visual, and also you'll see that, as well as you can on the video, that the samples come out side by side, pretty much identical, which is what we're hoping to see. Also, you may notice that the sample probe goes down to different depths in the different tubes, and that's by default. It has a default depth of 110 millimeters for your raw sample that's pulling up, and 80 millimeters when it's dispensing. That way it keeps the probe out of your final sample to preserve the integrity of the data as much as possible. So a quick summary, we've taken something that was a semi-automated system, and with the addition of our auto sampler and the software, we're able to do full automation for dispensing, diluting, sample preparation, standard preparation, what have you. The installation is very straightforward. It's very plug and play, and the software itself is easy to use, and we're going to go into the software a little bit more in depth in just a minute here. The goal, of course, is you move your sample racks, you prep them here, and then you can put them directly on the analysis instrument. And our hope with the system is that it will be a flexible tool that can be used across the lab by different units as they need it. So you may have someone from your IC group that wants to use it, and someone else who's running your mass spec also wants to do their sample prep on there as well. So the next thing I wanted to do is, hopefully this you can see this okay. What we have is a live camera feed of the system. It's seen from the side. My hope was that you'd be able to get a slightly better visual on the sample tubes as it runs. You can see the diluter off to the left there. And the sample probe is presently at the rinse station on the back right in that pane. And in the right pane is the actual software itself. So what I've set up here is just a little dispense protocol, and then I'll open up a second sequence for dilution. There are some a few drops of some brightly colored liquids in the bottom of those tubes to hopefully provide a better visual as it dispenses. So the first thing it does is it always starts with an initialization to make sure that the system's communicating appropriately, and now it's doing its first rinse. This essentially serves as a prime cycle to make sure that you have fresh diluent in the system for when you actually start running your samples. Now you should see it in the first tube. There it's dispensing. And because this is just a dispense protocol, it doesn't have any sort of a rinse program, so it'll go directly from one tube to the next. Hopefully you can see the big syringe is the only one moving. As it's not pulling up any sample aliquot, everything is directly controlled by the large syringe to facilitate the speed. And the software is designed that it will automatically select from the syringes installed the best syringe to give you the best accuracy for any movement that you program it to do. Okay, so that's our first step. We dispensed into those tubes, and now we're going to try and run that at 1 to 10 dilution. Have the right file. So again, it does its initialization, and then it should go on over to that the red tube, pull up an aliquot of it, and dispense into the tubes on the right. Okay, again, we've got that first wash step. So the sample's pulled up by the small syringe, and then your diluent's pulled up by the large. As you can see, the small syringe dispenses a lot faster, which provides some sort of basic mixing as the sample gets introduced into the tube first, and then the follow-up diluent provides sort of a introductory mixing of the sample. That's not the mixing step that you can add additionally, but kind of the base function. And off to the right, you can see as the software goes from sample to sample, you've got blue checks for samples that are finished, the kind of a light blue circle for the sample that is presently in process, and then the green arrows are for samples that are still to be run. So it does provide you a continual readout of where you are in process for your sample dilution. All right. After it rinses, it's going to go on to that final sample. And then the next thing we're going to do is I'm going to open up the software a little bit more, just to give you a sense of how it works and how you would interact with it on a daily basis. All right. So hopefully you guys were able to see that. I don't know the quality, how well it would carry the video over. Hopefully it wasn't too choppy and you're able to see some of the video. So the software itself is really pretty straightforward. I mean, it's essentially designed like an Excel spreadsheet for the most part. So I'm going to blow it up here and just highlight some of the things that I think are most usable or most useful to kind of the average lab user. one thing that it, just going across the top, it does provide some basic information about the sequence in question, so whatever samples you're running like that day. Start date and methods date. So the start date would be the time that the samples actually run, or like when you began your dilution today. Your method date is when that was last altered. And then you have current user and method creator. So within the software, if you want, you can create 2 different levels of user. You can have an admin, and only the admin has rights to change things like the syringe sizes and a lot of the system settings, whereas the user can still open and run all the methods. Then your diluent, really that's just a reminder. It doesn't affect anything analytically speaking, but the diluent mark is there to make sure that your system diluent matches your sequence diluent. That way, if you have prep A that uses nitric acid as its diluent and prep B that uses just water or a mix of nitric and hydrochloric or something like that, then when you open up the sequence, you have to make sure that the diluent matches between the system and the sequence to ensure that it's just kind of a reminder for the user that if they do need to change what's being used for the diluent, they take that extra step and remember to do it. And then the rest of these just select your rack positions. So the racks that are presently supported are all the standard Bell Art racks, 21, 28, 24, 40, 60, 90. And that also supports the Gilson racks and HPLC vials. And then within this kind of main frame, you've got your status bar. If you click up here, and it affects everything within the whole sequence, which is a handy feature. And then you can copy and paste within this field to change values. You select your standards just from a drop-down list if you do want to add a standard spike. And this whole thing can be printed, and it can be copy and pasted within Excel. So if you wanted to take your whole sequence and paste it into Excel file, you can do that. You can also copy from Excel and paste into this program. Some of the main settings to be aware of. So within the station settings, that's where you would normally change things like your syringe sizes. If you do wind up using different types of syringes, this is where you'd make sure the software matches what you presently have installed, and also where that diluent is listed. And then your sequence settings are what I think really gives the power to the user within the software, because it allows you to essentially add or remove time by adding and removing functions. So you can, and I normally recommend having an air segment before the sample pickup, because it does create a separation between your sample and your diluent, and helps with washout and helps to reduce carryover. The no drop volume after is more of a safety, just to make sure there's not any drips. It's a little less necessary, but it's kind of a nice feature if that's something you're concerned about. The dip into wash port helps rinse off the outside of the probe. So between movements, it'll go back to the rinse port, dip in, just in case there's anything on the outside of the probe to give it a chance to wash that off. And like I said, your rinse is totally user configurable, so that's all in your hands. There's the initial volume, which essentially acts as a prime, and your volume between samples, which is where your rinse usage will come in. And that is a dispensed value. So it rinses the inside of the probe because it dispenses that volume out to ensure that the probe inside gets rinsed. But also the Prairie pump will of course turn on the auto sampler. So if you have a rinse solution hooked up there, it will also rinse the outside of the probe that way. So you get kind of a double rinse to make sure that things get really clean. And then the mixing we talked briefly about, but you basically select a volume and the number of iterations, and that I believe goes up to 9. There it is. I was going to say 10, but so that's another option. It does add a fairly significant amount of time, so it may not be practical for everyone. but it is another option built in, one less thing that you have to worry about doing by hand, and one more thing that you can automate. I think that's about all I wanted to cover in terms of the software. So at this point, I wanted to just start going through some of the questions. So if you do have any, please send them on. I do have a couple here that I'll start with. If there's anything else you want to know, please go ahead and type it in the chat and let us know, and we'll go ahead and answer them. I do have one here about the spike, or how did we do our carryover testing. I think this was covered, but just in case, I'll go through it one more time. The carryover study was done follow-up to our standard prep. So we did our calibration curve study, and we did a carryover study side by side. So we had the diluter system prep our calibration curve off of a 100 ppm stock solution. And we prepped the high standard last. Directly after that, and that was prepped at a 1 to 10 dilution, so a final concentration of 10 ppm. Directly after that was prepped, we prepared a blank just the same way as a 1 to 10 dilution. And then those were run on the ICP. We paired that blank with the initial blank at the beginning of the calibration curve for a comparison. And that's where the carryover data came from. And we did use some fairly significant mixing and rinsing parameters on that. But that's, again, it's totally up to the user. So depending on the needs of your lab, you can add or remove rinse time to optimize performance for your own system and what your own needs are. Another question is, what is the time per sample? This is a pretty common question, and it really varies. Again, it's up to the user to some extent. Standard 1 to 10 dilution, like we showed here, typically somewhere around 30 to 35 seconds. For dispensing, it's more like 15 seconds, 10 seconds, depending on how much you're dispensing. The greater the volume, the greater the time. So that's up to the user. And again, if you're adding in mixing or you have particularly high rinse requirements, it might take a little bit longer. You may be able to trim that down as well by cutting out some of the other nice features if you want it to really crank along sample to sample. It just depends on what your analytical requirements are. Can the system be used with multiple solvents? That's something we're looking into. There's a hardware fix, but I think for most labs, the answer is yes, if you wanted to. The easiest thing to do would be, of course, you've got your solvent A bottle and you've got solvent B, and you just move the tube from one to the other, and then prime the system again before you start running samples. And then you've got a different diluent being used. If you wanted to switch mid-run, that's presently something we're investigating. There is a piece of hardware, a switching valve that can be incorporated into this, but at this point, we haven't seen a lot of demand for it. So if it's something you really want, let us know. We'll spend more time on it. As far as the software itself goes, if you ever want to get more time or become more familiar with it, please let me know. We can send out copies of the software for testing or for evaluation. Because the software is locked down by the cables being used, the communication cables provided essentially act as the copyright protection for the software. So the cables are specific to the system. They're specially made USB to serial cables that help protect the software. But if you want to open up the software, get a copy and play with it, that's something that we can provide. Another question just came in. Any routine maintenance needed? There's very little. Honestly, I mean, you run an auto sampler, you should be aware of most of the maintenance required. If you're rinsing normally, it shouldn't be a big problem. The probes do eventually wear out. They wear out faster if you forget to remove the caps from your 50 ml vials, of course, but they will eventually wear out. And we recommend those being changed out on a yearly basis, but it really depends on how well you take care of it. The only other maintenance really is trying to keep the system clean. And of course, the ferry pump tubing on the back will wear out. That again, is we recommend a yearly maintenance. As far as the syringes go, if you do start to see buildup on them, they're really easy to take out and clean. There's actually a syringe removal button in the software that makes it really easy to take them off. And typically with the Hamilton syringes, all you have to do is open them up and wipe them out, and then you put them back together and you're good. So maintenance is really very limited. Okay, I've got a question from Dwayne. In the coolant video, there's slightly different probes used. We found we were using in the coolant video an old Ultem probe. I think it was mainly just because that's what our lab had on hand when we were doing our testing, and that was a very early video. It is available with any of the probes standard to the 520 or 560. So carbon fiber, there's the no drip probe that you could be used, and we do still offer the Ultem probe. As far as something specifically designed to take up small volumes, we don't have anything specifically marketed for that at this point. There was some belief that the Ultem probe might be a little bit better because it has a finer tip on it, but we have been able to get really good accuracy results for something the size of 100 microliters with the standard carbon fiber. And the issue that you run into with using a small probe or something that's specifically designed for low volumes is then you have to also reduce the speed of the syringes so that you don't cause a pressure buildup and potentially damage the syringe. So at this point, we're just using the standard 1 ml probes to try and reduce the restriction on the line as much as possible. But we have been able to get good data with that for something as small as 100 microliters. And we found that really the key thing is ensuring you have the right size syringe if you want to get into really small volumes. But with the 1 ml syringe, I mean, that's easily within the range of a 1 ml syringe, the standard setup. Okay. All right. Well, I think if there isn't anything else too pressing, then we'll go ahead and close for today. I'll turn it back over to Shelley.